Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today to help you explore artificial intelligence at home. I'm going to need you to pour yourself a nice big mug of iced coffee. I am going to need you to get out your Jetson Nano gear, and I am going to need you to get ready to learn some cool new stuff. Let me start with what my assumptions are in putting this video tutorial together. My first assumption is that you are not a computer science expert, that you don't have a PhD in computer science. My assumption is that you're probably coming from another single board computer like the Arduino or maybe the Raspberry Pi. My assumption is that you watched my last video, which was the fundamentals of Linux. So at this point, you know your way around the Linux terminal. And then today, what I'm going to teach you are some of the basics of Python. Now, why are we doing this? Because way too many of you guys that are getting these single board computers get them, run out and run someone else's demo program or type in commands that you found on the internet and then get the board to do something really cool. But then you guys are clueless as far as how to go out and develop something on your own or put your own ideas into effect. And so you've really got to have some foundational knowledge to go beyond just running other people's programs. And what we sort of figured out is the two fundamentals that you really need to understand are how to work your way around the Linux terminal. That was the last video, and then today's video is the basics of Python. Now with those two things, you have the foundation that you can go out and start doing the learning that would allow you to do artificial intelligence at home on your own. Hey, you want to see some cool stuff I'm doing just to sort of show you where I'm going with Python? Let me show you a program that I was working on today, and I won't really go over the program other than just to show you that it is 37 lines long, which means you could write this program in an hour, and it really draws on a lot of the different stuff that I'm going to be teaching you today. And what does it do? And again, I wrote this program from scratch, and what it does is I have trained through transfer learning a deep neural network to recognize single board computers. So you can see we have a live video here. And boom, it recognizes that board as the Raspberry Pi Zero. Now I can come over here and I can move that and put this one there. Shazam! Look at that. Recognizes it as the Arduino Uno. I can come in and put this one here, and it recognizes that as the Arduino Nano. And you see you can kind of put it at different angles, and it still recognizes it. And then for the big finish, we come in, and boom, it recognizes that as the Raspberry Pi 3. And so this is what you can do with a Jetson Nano in 37 lines of code. And this wasn't like I downloaded someone's program or I downloaded someone's model. I used the NVIDIA inference libraries. I retrained the models for single board computers, and now I can recognize single board computers. Okay, I like to live dangerously. I'm going to see if I can move this over here and look at the Nano and see if it can recognize it. It is reading it as the Jetson Xavier. There it is. It sees it as the Nano. And then I've got an Xavier over here, but it is under so much junk. Yeah, it recognizes it as the Jetson Xavier. There it is. Okay, so that is pretty darn good for a new guy to all of this stuff to be, writing 37 lines of code that will be a individually trained deep neural network through transfer learning. So why do I show you that? I show you that because we can take you to the point that you can do this on your own. I did this on my own. We can get you to the point that you're doing this on your own. But to get there, you need to understand Linux, the last video that we did, and you need to understand Python. So I am going to get this nonsense out of the way, and we're actually going to start, instead of looking at what I did, we're going to start actually teaching you. So I will get all of this out of your way, and what I am going to need you to do is open up a terminal. All right, we learned how to do that last week. You right mouse click and then you say open terminal. And then I am going to get out of your way here. Okay, that is not what I want. I am going to get out of your way, and we're going to jump in and we're going to start learning Python. Again, I know a lot of you guys are like coming from Arduino, and so I'm going to assume that you sort of kind of have the concept of for loops, if statements, declaring your variables, clauses, all that sort of stuff. But I'm going to kind of show you some of the unique things about Python so you can take what you know and then you can understand how Python works, because there's a lot of things with Python that are very similar to Arduino, but then there's some things that are really different, and if you don't know those different things, you can end up with some massive headaches. So the first difference is that with Arduino, you write the code, it's more like C. It compiles the whole thing and then it runs that compiled code. And then it gives you error messages that usually kind of don't make any sense at all. And so Python is different. Python interprets one line of code at a time, and it kind of like every time it sees a line of code, it compiles the line of code and then runs it. And so the downside of that is, compared to something like C, Python is really slow, but the upside of it is it's much easier and more intuitive to program in it. Now, some of the stuff I think you're going to like a lot better than C or a lot better than Java or Arduino, and then some of the stuff maybe you aren't going to like so much. But let's just jump in and kind of show you that first of all, Python is execution ready and you can just do one line of code at a time. And so if you call up your terminal, you can actually run lines of code from the Python shell. How do you get to the shell? Well, right now you are in the Linux terminal, because you see the little $sign. Linux is waiting for a command. So I will give it a command, and that is, if I can come here, that is Python 3, which will launch the Python 3 shell. Why Python 3? Because Python 2 is deprecated, so we always want to say Python 3 so that we are on the modern supported version. Now all of a sudden you see the 3 greater signs. That means that we are at the Python shell. So let's just do some stuff like just say, I could say x equal 3, okay, and then I could say print x. Well, it remembers that x is 3. That's pretty cool. Well, let's say I can say y is 2, and then I can say z is x plus y, and then I can print z, and I get 5. Okay, so you see that works. Now, what's the first thing that you notice about Python that is different than a lot of other languages? You don't have to declare your variables. It just sort of figures it out. Now you notice that it made, like I never declared z, but it printed out z as an integer because there's no decimal point. And so it sort of figured out, and this is kind of the interesting thing about Python, it started saying, well, x is an integer, y is an integer, z he probably wants as an integer. So what if I said, x is equal to 2, and then y is equal to 3.0, and then I say z is equal to x plus y. Well, when I made y 3.0, it's going to say, well, he wants y to be a float and he wants x to be an integer. And so when I say z is x plus y, and then I say print z, you see, it's got to kind of figure it out, and it says, well, one of them's a float, so I better make everything a float. But you see, what this means is Python is kind of figuring out things on variable types, and you can sort of get in trouble with that. Another one is like if I said z is equal to, if I did this in Arduino, if I said z is equal to 2 divided by 3, Arduino is going to make z 0, because it's going to say integer 2 divided by integer 3 is the integer 0, because I can't give a decimal, so it's going to give you 0. But here, the interesting thing is what Python does is it says, well, an integer divided by an integer, maybe it's an integer, but I better go ahead and make it a float. Okay, so you see, it's you got to be careful with your variable types in Python, because it gives you enough rope that you can hang yourself. So I usually try to kind of force it. So like I would say x is equal to 2.0, y is equal to 3.0, and z is equal to x divided by y, and then I can print z, and then you see as I'm forcing things to be floats, it leaves less ambiguity in the whole thing. So that's kind of something to keep in mind. Now the other thing, I guess the other big difference between Python and Arduino is that in Arduino or Java type languages, your clauses or your groups of code is like an open curly and a closed curly, and anything between the open curly and the closed curly is that clause, whether it's a for loop or an if statement or a while loop or whatever. The clause is within those curly brackets. Now that's real clean. That to me is a real clean way to do it. The way Python does that is it keeps track of clauses through indentation. And the hard thing with that is sometimes you can end up with problems about the difference between a tab 4 spaces versus 4 spaces on the key on the space bar. And so you can kind of get in a little bit of trouble if you're not really careful with that indentation. And so just understand that indentation is very, very important in Python, and you've got to do it very, very carefully. Okay. The other really neat thing about Python is very, very powerful when it comes to arrays. Okay, it's very powerful when it comes to arrays. So I could say x is equal to the array, and then I could make it 1, 2, 3, 4, and then like that. And then if I say print x like that, then it prints the array 1, 2, 3, 4. Well, I can index that really easy. So I could say like print x and then print x of 1. Okay, so I want to print the first element of x. What do you predict that this is going to do? Okay, if you predicted a 1, you are wrong, because the 1 is not the first element of the array, it is the 0th element of the array. And so in Python, you think like programmers, where you start counting at 0 instead of counting like normal people who would start counting at 1. And so the 0th element is 1 and the first element is 2. So that's something that you got to kind of remember, that Python starts counting at 0 for arrays. But now the reason arrays are really important is when you get into artificial intelligence, you're dealing with large amounts of data, and large amounts of data, you keep track of them in arrays. And so this is a one-dimensional array. You can also do two-dimensional arrays. And why is that important? If you think of a picture, you can think of a picture as a lot of pixels, and each pixel has a row and a column. So you have a whole bunch of rows in a picture and a whole bunch of columns. That is a 2D array. Well, how does that work in Python? Well, I could have x is equal to, and then I could have my opening parentheses, and then 1, 2, 3, 4. Okay, that is the first row. I close the first row, and I put an 11 there by accident. I close the first row. Okay, and now I make the second row. I could say 5, 6, 7, 8, and then I close that row, and then I could do the last row, and that would be 9, 10, 11, 12, like that. And so this is a two-dimensional array. There are 3 rows that are kind of separated by columns, and then you're bracketing the row together. There are 3 rows and there are 4 columns. Okay, and then if I put that in, and now I say print x, okay, it prints that out: row 1, row 2, row 3, row 4. Well, what I could do is I could say print the first row. Oh, we start with 0, so I could say print x, and then I could print the 0th row. I just should not have there. I could print the 0th row like that, and what I get is 1, 2, 3, 4. I could print row 1, which is really the second row, and I get 5, 6, 7, 8. So you see, I can index a given row. I can then also index an element in a row. So what I could say is I want row 1, and then what I want is element 1. Element 1. So what is that going to be? Row 1, element 1. Can you guess what that is going to be? It's going to be 6, because the 5, 6, 7, 8 is the row 1 comes after row 0. It's row 1. And then 5 is the 0th element of that row, the 0th column. And then 6 is the first column. Okay, so 6 is the element x1, 1. So you see, I can have an array and then I can index it. Now, if this was a picture, you know, what we would have in there is we would probably have a number between like 0 and 255, so sort of like a range. Or it could be RGB, where at each point we could have 3 numbers, the R value, the G value, and the B value. So we would have a multi-dimensional array where you have a row, you have a column. At the intersection of the row and the column, you have 3 numbers, a number for R, comma G, comma B. And so you could index not just the pixel, but then the red value, the green value, and the blue value of the pixel. And so arrays, as we get into artificial intelligence, are super important. And this is just a quick tutorial of letting you kind of see that you think in terms of rows and columns, and it's a 2-dimensional array, and you can index a whole row or you can index any given pixel that you want. So that is a quick primer there. You can also, and this is kind of important, and this was really sort of counterintuitive to me. Like, I come back from way back in the days of Fortran, where you have like for j equal 1 to 10, you know, in steps of 1, something like that. So I think of a for loop in terms of I and j are integers, and I step through those integers. It's just the way that I was brought up. But the interesting thing with Python is I could make my array, I could make it apple, orange, and banana, like that. Okay, and then print x. Okay, so I get the array apple, orange, banana. So now what if I print x1? What do you predict that is going to do? Okay, that is orange. Now, what would you say would happen if I did x1, 1? Okay, this is kind of like Python just sort of does stuff on its own sometime, but what would you say that would do? That gave me R, because it's treating now, oh, he must want to divide up orange. Okay, I'll index it, and the 0th element is O, and the first element is R. And so Python is very powerful to allow you to kind of index through just about anything in lots of different ways. But also what you can do is normally in a for loop you would go from I equal 1 to 10 in steps of 1. But in Python, I could step through this array, and the first time through it's apple, and the second time through it's orange, and the third time through it's banana. Or I could step through more complicated data structures. And when you first get started with that, it can be very confusing, but then it turns out to be really powerful, because almost like if you do something in artificial intelligence and you call a library and it returns to you a complex data structure, like let's say something like contours, I can just say I can step for contour in contours, and then it will step through each one of those elements in this rather complicated data structure. And so as we get into it, you're going to see that it's very powerful, but you just got to think of it as an array. And Python will step through any array, and it will put just about anything in an array, and it will allow you to have really goofy shapes in your array. And so it's very flexible in the type of data and the arrangement of data that you can use in an array. Okay, so I think I have talked enough about arrays, and we need to exit the command line, and you get out of the command line by putting a Control-D, and that will take you back to your Linux terminal. And we need to actually see how to write a program. Well, we need a text we need a text editor. And so There's kind of an old school one that I will show you. You can see that for my real development, I use Visual Studio Code, and you can search my channel. I've got a lesson on how to install Visual Studio Code, but I like kind of going back old school and using a text editor, because I want you to see that really when you write a program, you're just writing a text file and then the Python interpreter runs that. And so if I have something fancy like Visual Studio Code, all it is doing is it is a fancy text editor. And so let's install a simple text editor. We used this a little bit in the earlier lesson, and this is just a reminder of how do we install something. Well, we do sudo because we want to be the super user, and then we want to install, so we do apt-get and then install and nano. Okay, this is not the Jetson Nano. This is an old school text editor called Nano. Doesn't have anything to do with the Jetson Nano. It's just two totally different things with similar names. So I'm going to install that. It is reading it. It is going out and getting it. And it just takes a few seconds, and this thing should be up and ready for us to use. So you guys go ahead and install Nano if you didn't keep it from the last lesson. Okay, now let's do an ls to see what we have here. We've got our standard folders here inside. Oh, I shouldn't say folders, directories. I'm trying to break the habit of saying folders. We're Linux guys. These are directories. We're not Windows guys. Okay, so I'm going to make a directory, so mkdir, and I'm going to call it Python files, like that. Okay, now if I do an ls, there is Python files, so now I'm going to cd down into Python files. And if I work in this, I won't have to worry about paths, just whatever I save will be saved into this folder. So now I'm going to write my first simple program, and I think what we will do is I will just say nano, and then my nums, and then .py. The .py is kind of important because it clues your editor in that it's a Python program. It'll give you some helps, like it'll highlight text and things like that. And so giving it the .py will clue the editor in that you're dealing with a Python program. Okay, so we come up and we are now in Nano, and now we can write our first program where we will execute it separately. So I can say something like, oh, I don't know, let's say x is equal to 5, let's say y is equal to 7, and then let's say z is equal to x plus y, like that, okay? And then I'm going to do a kind of a fancy print statement where I'm going to kind of stack things together, and you separate the things that you want to print with a comma. So I'm going to print x and then a comma, and then I'm going to print the string. So the string is going to go in a quote, so the string is going to be a blank and a plus and a blank, okay? And then a comma, because now I'm going to print the next thing, which is y. And then I'm going to print a comma, and then I'm going to put another string, which is going to be equal to and a space, okay? And then I'm going to put a comma, and I am going to print z, like that, okay? And now how do I save this? I do a Control X. It says, do you want to save it? I will put a Y for yes. Where do you want to save it? That is fine. I could change it here if I wanted to, but no, I'm not. I'm just going to click enter, and there it is. Now I should be able to say Python 3, and I should be able to run my nums.py. Okay, 5 plus 7 is 12. All right, so we wrote our first simple program. Let's come back up here and let's nano it again. I'm hitting the up key to get my old commands back to save time. That's a little pro tip there. Okay, so that is kind of neat. What we could also come down here and say, we could say print, and we could print that's all folks. Like that, okay? And this shouldn't surprise you. I put it in quotes, so it's a string, right? And so I can Control X, yes, and then I can up, and Python 3 NumPy, and 5 plus 7 is 12, and it prints the literal string, that's all folks. All right, so now what I could do is I could come back up here, and instead of that, up here at the top, I could say that message, MSG, is equal to that's all folks, like that. And then I could come down here and I could print MSG. Okay, now I want you guys to look at this and I want you to tell me what this is going to print. Okay, in your mind, think, what is this going to print? Look at it carefully. Okay, so it printed MSG. Okay, did you catch that? All right, why did it do that? Because I put MSG in quotes, so it printed the literal string MSG, not the variable MSG. If I put it like this, MSG, the variable MSG, it's going to print a string, but it's the string that belongs to the variable MSG. Again, you got to kind of think about data types and what you are dealing with here. So let's Control X, yes, and then let's up, and Python 3, there. 5 plus 7 is 12. That is all, folks. Okay, so that is pretty good. All right, let's look at one other thing, kind of another thing that's pretty useful here. Let's say that we had X is 5 and Y is 7, and Z is X divided by Y. X divided by Y, and then here we would put a divide sign just so the formatting is right, and now we are going to Control X, Y, yes, and then we're going to run that. Okay, and so it says 5 divided by 7 is 0.71428571428571443. A little bit annoying, isn't it? And so one of the first things you want to do, like, we're going to be out, like, you remember that program I just showed you where we were calculating frames per second? You want to see frames per second in something that's easy to read. You don't want 14 decimal places. So what you can do is when you are doing a print like this, what you can do is you can say round, and I am going to round Z to 2 places. Now I'm going to close my round and then close my print. That looks good. Control X, yes. All right, then we're going to come up and Python 3 num2. Look at that. 5 divided by 7 is 0.71. That's really cool. Okay, that makes it a lot easier and a lot more readable to be able to round off your floating point numbers. And that is something I find I need to do a lot of times. Also, I guess that what you could say is you could say W equals round of Z comma 2, like that. And then you could come down here and you could just print W like that. So you see you can actually assign it to a variable. Let's try that. Okay, we got the expected results just like we wanted. So I think that is pretty cool. Okay, so let's come up with another one. And I think that what we want to do now is we want to look at conditionals, okay? Because conditionals are if statements, and we got to kind of see how if statements work. What I want to do is I want to do if statements, I want to do for loops, and I want to do arrays today. So if, for, while, and arrays, all right? And so we are well into this thing. You guys are doing great. You are doing great, but let's do let's do a nano, and it'll be a new one, conditional.py, like that. All right, and so now what I am going to do is no. Okay, what I'm going to do is I'm going to do input. So user input, like that. All right, and so now what I'm going to do is, how do you get input from the user? Because that's something fundamental that you are always going to do. And so what I could say is X is equal to input, and then inside of this I will put the prompt, what is your number, like that. Okay, input, what is your number? Let me say, what is your first number? Okay, and then Y is equal to input, what is your second number, like that, and then print your first number is. I always like to put a space, so keep your formatting good. Do you see how I put a space so that it won't just run the thing into it with poor formatting? And then I will put a comma and X like that. Okay, and now print your second number is space and then comma Y. All right, and so let's run that. Control X, yes. Okay, and then I am going to Python 3 user input dot py like that. Okay. Ooh, what happened? Oh, denied. Nano user input. That looks, I didn't get that first quote in. There we go. Control X, yes, enter. Were you guys yelling at me for that? Okay, Python 3 user input. What is your first number? My first number is 2. I thought I put a space in there. That is very poor form. We'll fix that in a minute. Your second number is 3. Okay, and it says your first number is 2, your second number is 3. All right, I put the space in when I printed, but in asking I didn't put it in. So what I need here is over here, I need to put in a space so that when you type in your answer, it's not jammed up against the question. So that will be much better. Control X, yes. And you really want to format your code nicely. Make your code look good when it's interacting with the user. All right, Python 3, okay. First number is 3, second number is 2, okay. And that looks good. Okay, so now let's go in and let's do a little bit more. So we're going to nano this. Okay, now what we're going to do is we're going to say Z is equal to X plus Y, okay, and then I'm going to print your sum is, and then a comma, and I'm going to print Z. All right, now I want you guys to think through this, okay? You're going to input X as 3, you're going to input Y as 2, and then you're going to say Z is X plus Y, and then you're going to print Z. Okay, write down what this is going to do. Okay, write down what this is going to do and tell me. All right, so what's it going to do? I'm going to, I nanoed it instead of Python 3ing it. There we go. Okay, my first number is 3. Okay, my second number is 2. What is it going to do when I press enter? What is it going to do when I press enter? Unexpected, the sum is 32. No, 3 plus 2 is not 32. Okay, and why am I doing this? Because I want you to see the trouble that you can get into in Python, again, because you don't declare your variables. It sort of assigns variables as it will, so you got to really pay attention to variable types. So let's go in and let's see what just happened to us. All right, when I did that input, 3 is not particularly special. And so Python read the 3 as not the number 3, but the character 3. It read it as a string 3 and a string 2. Well, in string world, plus is not addition, it's concatenation or combining. So like hello concatenated with world is hello world. So hello plus world is hello world. It's not H plus W. Right? It just strings them together. And so this concatenated the 3 and the 2 into 32. And that's because we are not being mindful of variable types. Because you don't declare your variables, you don't think about them. What we need to do here is we need to say we need to take that input and make it an int. Okay? And then I need to close that, right? And then I need to come down here and I need to say y is an int, not int for integer. Integers are your round numbers, and we go like that. Okay, Control X, yes, and then we're going to Python this thing. Your first number is 3, your second number is through. Boom! 3 plus 2 is 5. Okay. Now this seems really simple, but man, if I do it in a simple little program like this, it's really clear. But when you get in the middle of a big, ugly, hairy problem and you ended up with a string when you thought you had an integer, life just goes really bad, because sometimes that might be a parameter that you're passing to another program, and you thought you were passing it the int 3, but you were passing it the string 3, and then the program crashes, and you go crazy because it's hard to debug, because you're looking, okay, well, I'm going to print X, and it prints it as a 3. And you say, it's 3, what's wrong? Well, it's the character 3. It's not the string. I mean, it's the character 3 or the string 3. It is not the number 3. So you got to be really careful in Python to be very mindful of what type of data, the data type of your variables. Okay, so let's see here. Okay, so that was user input. When you do your user input, make it what you want. Okay, so you could make it a float. Let's try that. Okay, let's do one more and then we'll move on. All right, I could, instead of an int, I could make this a float, and then I could make this a float. Floating point is if in the math world, that's a real number. Okay, so it's the in-between numbers. Okay, so now let's do it, and we say 3. And we say 2, and look, now your sum is 5.0. Now there's a big difference between 5 and 5.0. 5 is an integer, 5.0 is a float, and things go really, really different sometimes between integers and floats. So even that, you've got to keep track of, are you using integer math or are you using floating math? All right, because it can cause differences later on. So one of the tips of being successful in Python is be very mindful of your data types and your variable types, because it is easy to get in trouble. Okay, so we have done user input. Let's move on to conditionals. And so I'm going to nano, and I'm going to say conditionals.py, cond.py. Like that. And then what I'm going to say is, let's say x is equal to, and we're going to be smart, we'll go ahead and make it let me make it an int. Okay, and I'm going to say int of input of please enter, you notice how I'm polite, I say please enter your number of interest. Which number are you interested in? I'm going to put a space so the answer doesn't run into the question, and then I'm going to close out that prompt. I'm going to close the input, and I'm going to close the int. Okay, and now the first thing we can do is just say print x. There should be nothing unexpected here. All right, so we will Python 3 now. Python 3. Okay, my number of interest is 3, and there's 3, and it's an int. Okay, nothing all that surprising there. So now let's come back, and now let's get into conditionals. All right, so now what I'm going to say is, and you're going to see how to do conditionals now, and they are very similar to Arduino, but some things a little bit different. So I'm going to say if, and then what am I going to say? If x, the number, is greater than 0, okay, then now this is what you see. I begin the clause with a colon, and I keep track of the clause with indentation. And so now, because we use the .py when we open Nano, it knows it's a Python program, and so when I click enter, I lied. I thought it was going to give me a tab, but it didn't, but I'll put the tab in. Okay, if x is greater than 0, then print your, or I'm going to be kind of fancy. I'm going to say the number and space, and then x, and then space is a positive number like that. Okay, now what I could also do is I could say if. Now you notice that as long as you are indented, that is the if clause. As soon as you stop the indent, then that is the first statement after the if clause. So now I'm going to say if x is less than 0, then what are we going to have? We are going to have to tab again, and then I'm going to say print the number space x space is a, I missed a space there somehow, is a, I really messed up. What did I do? Okay, x space is a negative number. Okay, and then what we can say is if x equal 0, then print your number is 0. Okay, now why did I say that? You know, people actually argue about whether 0 is a positive or negative number, and so they can't argue with me because I avoid the question. I say your number is 0, and so I don't even get into that debate. Okay, I have an error in my code, and can anybody tell me what the error is? And the reason I ask you, because this is like one of the most common errors that I run into that either I make or other people make, and it is one of the most difficult one. This one will make you change your major. This one will make you change your major out of engineering or computer science because the code looks so right, but it is wrong. And that is when you are doing a conditional, you can't say if x equals 0, you have to say if x equals 0, because if you say if x equals 0, all Python sees is x equals 0, and it makes x equals 0. If you say equal, it's a question. If you say x equals 0, you're making it 0, and that is a nasty problem. All right, so let's, so we have 3 different if statements, and then we will print again, just to be complete, MSG, okay, and then we'll set MSG up here. MSG is equal to, that's all, folks, like that. All right, so let's control X, yes, enter. I think we did this well enough that it's going to run. Okay, I really think it's going to run. Okay, my number of interest is 2. 2 is a positive number. Okay, minus 26. Minus 26 is a negative number. Let's run it again. Okay, 0. Your number is 0. Okay, so we've got if statements in the bag. Okay, in the bag. All right, now the other thing that we probably need to know is we need to know how to do compound conditionals, all right? Because like in Python or in Arduino, I think that you use the pipe, you use the bar, and you use the and sign, and it's a lot easier, a lot more intuitive in Python. Okay, so let's see here. So what I'm going to do is I am going to say z is equal to x mod 2. All right. Now, what is that crazy mod? That is like the remainder. So it's take x, divide it by 2, and what's the remainder? So if I said 3 mod 1, well, let's say if I say 3 mod 2, okay, 2 will go into 3 one time, and the remainder is 1. Right? If I go 5 mod 2, the answer is 1. Because when I divide 5 by 2, it's 4, and the remainder is 1. And so this is the remainder if I divided x divided by 2, then the mod is the remainder. So this is the remainder of x divided by 2. All right, so now what does this mean? I want to do a compound statement. So I'm going to say if x is greater than 0 and z is equal 0, then what I can say is a positive number, and then what I can also say it is a even positive number. All right, and so now we are going to see if we can copy and paste, which can be a little bit tricky. I'm going to take these 2 lines of code, right mouse click copy, and then I am going to put a space for it there. Nano is not very sophisticated, so now to paste, I've got to get right in the right spot, and then I have to right mouse click and paste. And so now I say if x is greater than 0. Okay, so we've learned how to do equal is equal, less than, greater than. You could imagine we could do less than or equal to, greater than or equal to, but also not. We need to learn not. And not is exclamation point. Oh, what did I do? Where did I end up here? I did something crazy. Okay, I wasn't where I wanted to be when I started typing. Okay, so right here, we want to say if x is greater than 0 and if z, which is the remainder of the mod, is not equal to 0. And so not equal to 0, in that case, x is a odd positive number. Right, now here we'll say if it's less than 0 and z equals 0, then it would be, we're going to use good English, it is an even negative number. And I need to use better grammar up here. And. Okay, so that would be an even number. And now we're going to try to do our copy and paste trick again. All right, so we will come up here and we are going to get this code. Oh man, I clicked on opening a program. I hate it when I do that. Okay. Die, you aggravating thing. It's like, how many times, how many different ways am I going to have to kill this? All right, we'll be more careful not to do that again. Okay, so now I'm going to copy it again just to be safe. Control C. And now I'm going to come here and I'm going to right mouse click and I am going to paste. All right, so now we have x is less than 0 and z is not equal. Oh man, you see, this is the problem. You can't put the cursor with the mouse. You have to get the cursor with the arrow key, and that's what happened to me before. It's a very crude text editor, but we're going old school today, right? Okay, so now that looks good, and then we're still not going to argue about whether 0 is even or odd or positive or negative. So Control X, yes, enter. And now we're going to run this and we're going to say, please enter your number. 3 is an odd positive number. 4 is an even positive number. And then -5 is an -5 is an even negative number. Okay, we have a mistake in the code. Did you guys catch that? Okay, so it says an even negative number. Oh, I see. We didn't change this to odd here. I copied and pasted, but I didn't fix it. Okay, so let's go odd. Control X, yes. All right, so now let's try that again. -5 is an odd negative number, and then let's try one more. We'll say -2 is an even negative number, and then we will try 0 just for fun, and your number is 0. Okay, guys, so now you see how to do conditionals. We did conditionals and we did compound conditionals. Okay, we did conditionals, compound. You have less than or equal to, greater than or equal to. You have equal, you have not equal, and those are your kind of big ones. That will be 90% of the conditionals that you will be doing. Okay, so we did conditionals, and so now I think we are ready to begin looping. We are ready to begin looping. And so I'm going to do nano, and I'll do loops.py like that. Okay, so let's just do the simplest possible for loop. So I'm going to say for, Okay, and you're going to say I is your index, and then n for I, n, and then you're going to do a range command, and that range is going to be from 1 to 11, and steps of 1, like that. And then you start the clause like an if statement with a colon, and then you are in that clause, in that for loop, as long as you are tabbed over. And so what I'm just going to do is say print, we are on loop, comma, I, like that. Okay, and so now let's go control. All right, now tell me what this is going to do. This is going to print which numbers? Tell me exactly which numbers this is going to print. All right. Okay, so I'm going to control X, yes. All right, so now we will Python 3 loops.py. Okay, loop 1 through 10. Unexpected result again. Okay, unexpected result. And this one kind of annoys me a little bit because I said start at 1 and go to 11 in steps of 1. And the thing is, it loops as long as the index is less than the end one. When the index, when I goes to 11, oops, I'm done, it's equal to, it's got to be less than. So you see, it always stops 1 before the end one. Now, there was a crazy rationale for them doing this because they think, well, if you start at 0 and then 11, you would really want to stop at 10, and therefore will always stop 1 early because programmers are always going to start at 0, and therefore it will do the right number of loops. And so it's kind of a crazy thing like that, but it really annoys me because I want to go 1 to 11 in steps of 1. All right, so that annoys me. And so if I really wanted to go to 11, I would have to go to 12, and I do not like that at all. Okay, so there I went to 11 because I put 12. All right, so let's look at another one. Let's say that I could do Python, I could do Nano, and what you could imagine is I could start at 2, and then I could step by 2, and then I could say, this would be the even numbers between 2 and 12, so I'm going to control X, yes, all right, and then I will run it. Okay, and so I got 2, 4, 6, 8, 10. But again, it didn't go to 12. It stopped 2 before 12 at 10, the last even number. So you see, this really, I don't like the range command because to me it is kind of confusing. So let's come in and let's play around with this a little bit more. Let's also kind of just have a little fun here and say MSG is equal to, again, that's all, folks, like that. And then after we come out of it, because I want you to see when you drop out of the loop, like if I come here and then say print MSG, okay, you guys tell me what this is going to do. What is this going to do? All right. You see, it prints that's all folks every time because that's all folks was indented. So that made it part of the clause. It did it every time. So then what we want to do is we will do it like that. Now what's going to happen? Somebody tell me what is going to happen. All right, it's going to go 2, 4, 6, 8, 10, and then say that's all folks. All right, let's see here. I think we could probably go 12 to 2 in steps of -2. Let's see if it'll do that. Control X, yes. 12, 10, 8, 6, 4, yes. Now again, it stopped at 4. It didn't go to 2. So I really sort of hate that. All right, I'll show you kind of another interesting thing again. And this was like really a surprise to me because I come back from the old Fortran days. And so this was kind of like unexpected for me. But this is kind of important because you run into this a lot of times when you're doing a library call, and the library will return kind of a complicated data structure, and then you'll step through that data structure. So let me sort of show you what I mean here. Let's say that I say that let me say that my return, something is returned to me, and what is returned to me is apples, oranges. Notice I'm putting them in quotes to make them strings. And then bananas. Did I spell banana right? B-A-N-A-N. I don't know how to spell banana. Apples, oranges, and grapes. Okay. Yes. And so I got to close it with a square bracket, close it like that. And then what I can say is for watch this. Watch this. This is what I want to call this fruits. This is an array fruits. Okay. And then I'm going to say for fruit in fruits. For fruit in fruits, and then I'm going to say your fruit is, and then fruit. So fruit is the singular as you step through the array, right? And so I'm going to control X, yes, and then I sure hope this works. Okay, your fruit is apple, your fruit is oranges, your fruit is grapes. That's all, folks. Okay, so you see how you don't have to just step through numbers. You can step through kind of like just about any data structure. So I stepped through an array called fruits, and the first time through, fruit was the first one apples, the second time oranges, and the third time grapes. Okay, for fruit in fruits, print your fruit is fruit. All right, so that is kind of neat. So while I don't like the range function, I really like the ability to step through things other than numbers. Now let's come back to that range function. Let me show you another reason I hate it. I'm going to say for I in range, okay, and I'm going to go 1, 11, 1 like that, and then here I'm just going to say I is, all right, and then I'll turn this to I. Okay, so you guys know what this is going to do. This is not surprising. Just to verify, it goes I is 1 through 10, as we'd expect because we went to 11. Well, a lot of times, man, when I'm doing math, and I am a math guy, I want to step in something less than an integer. And so what I really want to do is I want to go from 1 to 11 in 0.1, in steps of 0.1, the step size of 0.1. So control X. You guys tell me what this is going to do. What's it going to do? I went from 1 to 11 in steps of 0.1. Where's it going to start? Where's it going to end? Think about it. You got it? Denied. Denied. And that's why I hate the range function, because it will not accept a float here. You have to step in integer values. Okay, and so that, my friend, makes it fairly useless. So who is your friend in Python? And now we're going to learn something new. Okay, we're going to learn how to import a library. We are going to import the library NumPy. NumPy is for working with numbers in Python. And NumPy is extremely powerful math functions. And so who is your friend? NumPy is your friend. NumPy is your friend. So we are going to import NumPy, and then we want to import it as NP, because that's every time we call NumPy, we don't want to have to type out NumPy, so we can just type out NP. Okay, we can just type out NP. All right, so now what we are going to do is we are going to say for I in, instead of range, we are going to say for I in NP dot a range. So NP, the library that's the NumPy library, we imported it as NP, and now we're going to do the library function a range, and we're going to go from 1 to 11 in steps of 0.1, and that should be a comma in there. All right, and so now if we use np.arrange instead of plain old range, we will look at that. What is that crazy business? Okay, now the funny business that you're getting here is because it's a floating point number, you're ending up with floating point math errors. And so you can see that you are running into that floating point precision problem, but you can see it is counting in 0.1. So that, though, is an unexpected result. So tell me how we would fix that. Tell me how we would fix that. We would print round I to 2 decimals, like that. All right, and that'll take that little annoying float problem out of there, I do believe. Control X, yes. Okay, so boom. What do we like about this? We like that it starts at 1. It counts by 0.1, so we are within p.range. We're way ahead of range. We are way ahead of range, okay, because we are able to step in floating point numbers, and then if we use the round command, we can take off the annoying things. But what do we still not like? It stopped at 10.9 instead of 11, so to make this work, okay, let me come back here. To make this work, we would need to go to 11.1 in steps of 0.1, and then it should go to X. And so it seems like NumPy arrange inherited this annoying thing from the normal range. And so Control X, yes, and let's run that, and let's see if we can get her all the way up to 11. Okay, yeah, it went to 11. But that still annoys me because I think start, stop, and step size. That's what I think. And I don't like it when it doesn't stop where the number that I put in. So really, I am going to show you how I like it, because like I think I want to go from 0 to 2 pi and I want 100 points. You figure out the step size. Okay, I think in start, stop, and how many points I want, like if I'm going to plot a sine wave or something. And there's really a very nice way to do that, and it is, who is your friend? Who is your friend? NumPy is your friend. Okay, so this will be NumPy again, but it is going to be NP, and instead of a range, it is going to be the most unexpected len space. And so this is just saying kind of like space things out linearly. And watch this. I want to go, now this is really cool. I want to start at 1, I want to stop at 10, and I want 25 points. I want to start at 1, I want to stop at 10, and I want 25 points. Control X, yes. Okay, and so we will run this. All right, where did it start? 1. Where did it end? 10. How many points did it have? 25. So I specify what I want, and it gives it to me. And I care a lot more about number of points than I do about step size. So I tell it the number of points, and then it figures out the step size to give me exactly what I want. Exactly the starting point, exactly the ending point, and exactly the number of points that I wanted. So when I'm doing coding, I will, most of the time, if I'm like having to do some calculations or something, I will use the len space in my for loops. And so that, I think, is pretty neat. Okay, so let's continue on here. Let's go back. Let's look and see what all we did here. Loops, mynums, conditionals. I'm trying to think of, yeah, let's go to conditionals. And so I'm going to go back to nano con.py. And this would be really, if you think about this, you know how we kind of had to keep writing this program? Well, what we want to do is we would like to have this, like if you think of the Arduino, you've got the void loop that's always there and running. Well, we want to kind of loop over this and not have to keep running it. So what I can say is while, and I can do a while loop. And while will loop as long as the condition is true. Okay, while will loop as long as the condition is true. So what could I say? Well, I could say while, you know, I just want to loop forever. So while 1 equal 1. All right. Now what's wrong with this? I put the colon to start the clause. What's wrong? Everything down here is not tabbed. And so this all has to be tabbed in to make it part of that while clause, okay? And now the print has to be tabbed in, so it's still under that if. And so I've got to come in here and I've got to put all these tabs. And guys, use tab. Don't try to use space, space, space. Don't use your space bar in Python. That would be my input to you. Okay. And then here we do want this in there. And then that's all, folks. I guess we would, yeah, let's put that in there. Even though it's going to run again. Control X, yes. Okay, so let's run the Python 3 of the conditional. Python 3 of the conditional. All right. Please enter your number of interest. 3. 3 is positive, is an odd positive number. 2 is an even positive number. 7 is an odd positive number. Minus 3 is an odd negative number. Minus 84 is an even negative number, and 0 is 0. So you see, we can just keep running there. Now, we haven't written a nice way to exit the program, so we're going to have to kill it ugly. And really, when you run Python programs, we really want elegant ways to exit and shut things down nicely. But we can Control D and it will kill it ugly, and we'll get back to our command line. Okay, so that is what we can do. Okay, let's do another little thing. Let's look at arrays really quick. So I'm going to say nano my array.py, array.py. Okay, so let's say, how would I create an array? Well, you could see that I could create an array like x is equal to, and you kind of put the parentheses around it, and then you put the array itself inside the brackets. And so this would be 1, 2, 3, 4. All right, so we saw that we can do something like this. All right, and then we can print x like that. Control X, yes, enter, and then we are going to Python 3 this, Python 3, and boom, we get our array. Okay, but now this is the problem. How would you input those numbers in an array? All right, so you would kind of like think in terms of, like, this is intuitively what I would do. Okay, like intuitively, this is what I would do. I would do something like nums is equal to input of how many numbers do you want, space. Okay, now what's wrong with that? Can you tell me what's wrong with that? Yeah, I'm not thinking about data types. So what I got to do is make sure that I'm going to put it as an int. Int, why? Because the number of numbers that you have would be a round number. Okay, then I would think of like for I in range, okay, and in the range from 1 to nums, and then I would have to go plus 1, right? I would have to go plus 1 so that it went to nums. But I want to show you a trick. If I just start the index counting at 0, then it's going to stop at nums minus 1. But if I start at 0, then how many times is it going to go through the loop? Nums. Think about it. That's why I think they did it this way, but it is a little bit too crazy for me. And then comma 1. All right, and then the colon to start the clause, and then tab over, and then I would probably do something like my intuition would be to, like, let's just create an array. My grades array is equal to a blank array. Okay, and then my intuition would be to, like, say, okay, singular grade, my singular grade is going to be equal to, and then I'm going to say an int of a input of please input your grade like that. Okay, so now I'm going to ask him how many grades, and I'm going to go get the grades, and then I got the grade, okay, but what I'm going to do is, instead of doing that, I'm going to put it in grades, and I'm going to put it in grades of I. So the first time through, it'll put it in the 0 position, the second position, the third position, and so forth, all right? And then what I could do here is, outside of the for clause, I could just print that whole array of grades like that. Okay, so tell me, do you guys kind of know what's going to happen here? Control X, yes. And then I am going to Python 3 my array.py. Like that. Okay, now it doesn't like line 5 print grades. Now I'm not sure, that was not the error that I was expecting. Okay, how come it didn't even ask me here? Because it didn't like grades. That is a most peculiar problem. Let me just take that out and see. I'm not exactly sure what's going on there, but let's look at this. Python 3 my array. Line 6. Okay. Oh, I see what the problem was. I didn't close that. I've got to close it for the input, and I got to close it, and that's why it didn't like print grades. You see, it didn't have anything to do with print grades. It had to do with the missing parentheses there. So Control X, yes. You old pros probably saw that one. Okay, how many numbers do you want? I want 5 numbers. All right. And then please input your grade 1, and it crashes. Okay. And what does it crash with? It says list assignment index out of range. And this is kind of like another one of the annoying things about Python. All right, and this is what the problem is. Right. The problem is I created the array grades, but I created it empty. And then I thought, okay, I'll just stuff stuff in there, that I'll put something in the 0 position, in the 1 position, in the 2 position. But since I created it empty, it's sitting there empty, and it doesn't want to get bigger. And so you can't do this. Like in most programming languages, at least in my mind, you would do it this way, but you can't do it that way. What you have to do is you have to, like now let me just say, I'm just going to input grades because that'll be straightforward. I'll just input the grade. Okay, and then what I have to do is I have to say grades dot append. And what do I want to append? I want to append grade, right? So you see, I have to append the singular number grade into the array grades. And so grade starts empty, and then I append into it the first grade, and I append into it the second grade. So the only way really that you can stuff numbers into an array is to append them like this. And so I'm going to append the grade that I just read into grades. Okay, Control X, yes. And now let's go. Does that make sense? I hope so. Okay, I have 3 grades. Okay, 99, 98, and 100. Boom, my array appended 99, 98, and 100. So I think that is pretty cool. And you can see now, if you've got to input numbers into an array, you do it with an append and you don't index it. But now what I will show you is, I will show you now that it is done that way, we can index it. And so what I could do here is I could now say, for I in range, starting at 0 and then going to nums, all right, and then in steps of 1. And then what I could do is I could print, and then now I would print grades, the array of I. You see, I can index that array once it's there. I can index the array once it's there. We will here go back to our old, that's all, folks, like that. All right, and now up here outside of that first for loop, I'm going to put here print your grades are, like that, and then it should print them as a list. Okay, so I'm trying to show you can index an array once you built it, but to build it, you can't build it with indexing, you got to build it with appending. So let's control X, yes, and then let's run that thing. Okay. Whoa, I didn't get my closing quote on there. Hopefully you guys saw that. Right there, like that. Control X, yes. Python 3. Still not happy. Denied. I'm going back to Python 2.7 is what I did. Your print in Python 3 wants the parentheses, and I did years and years of Python 2.7, and therefore I forget to do my prints right still. Control X, yes. I hope it runs this time. How many numbers do you want? 3. And I'm going to say 99, 100, and 98. Okay, your grades are 99, 100, 98. That's all, folks. Okay, guys, I hope you're kind of seeing how this works. I think that this is pretty darn neat. Let me just do one more. Let me do one more with a while loop. Like, let me do this one with a while loop, and then we'll kind of wrap up this lesson. If you guys like this, give me input. We can do more lessons like this if you're finding them useful. Because again, we want you to understand, and we want you to be developing things on your own, not just copying and pasting other people's codes. Or if you're looking at other tutorials, at least you're understanding what they're teaching, because you understand the fundamentals of Linux and the fundamentals of Python. It's about understanding, not about copying and pasting. But let's see if we can do this with a while loop. So I'm going to say nano while loop dot pi, like this. Okay, and so I'm going to say j is equal to 1. All right, and then I'm going to say while j is less than or equal to 10, like that. And then what I'm going to say is print j. And I almost made that mistake again, print j. Okay, and then I'm going to say j equal j plus 1. All right, and then I am going to say print that. Notice how I keep making the same mistakes. That's all, folks. What is it they say? Wisdom is recognizing a mistake when you make it again. Yeah, if you remake the same mistake and you recognize it, you're getting wise. All right, so Control X, yes. And now let's Python 3 that. Okay, so it went 1 through 10 and said that's all, folks. So I know a lot of people, what some people do is to get around that A range problem and that range problem, you can do things with a while loop. Just set your index with j equal 1, and then while j is less than or equal to 10, it will go all the way up to 10, and then it will stop, and then inside the loop make j is equal to j plus 1. And I know a lot of people that just deal with it like that. And so while loops are really very, very powerful. And also while loops are good if you're like taking data, because you don't know how many data points, or you don't know how long you want to be in that while loop or how quickly the data is coming. So while loops can be configured a little bit more generically than what for loops can. So I know a lot of people that just do while loops. Where the for loops are very interested is like if you're in OpenCV and you get this complex data set back of contours, where contours is a list of arrays, and so it's an array of arrays, you can step through those data things with for loops very, very easily. And so that's really, you're going to see a lot of for loops when we get into OpenCV. So that is pretty good. I'm going to give you a homework assignment. Your homework assignment is to average grades. Ask the person, how many grades does he have or she have? How many how many grades do they have, and then you're to input that number of grades, and then you're to average them, and then you're to print out all the grades, and then you're to print out the average, and you're to have the whole thing in a while loop that after it does that, then it asks for the next set of grades, and you're to verify that it works the second time and the third time. Okay, that is your homework assignment. I hope you guys are having as much fun with this as I am. If you like this video, give me a thumbs up. Give us feedback if you would like to see more videos like this, and whether we should be trying to do more in this series. We would be happy to do it if there is some interest. So I am Paul McWhorter, and I am from TopTechBoy.com, and I will talk to you guys later.